All right, everybody. In the morning section, I forgot to talk about this, so I'm going to have to remind them to watch this. There's a big bombshell. It's not a secret. It's in the notes. This will be the same format. Oh, it should be of, right? The last two multiple choice questions on the final, and they will be numbers 34 and 35. What is or are the major products of the following reaction? Okay, well, that combination makes an epoxide, and normally you're going to get a 50-50 mix of these two epoxides, where you have the O's on a dashes each. So in terms of stereochemistry, that made this a wedge and that a wedge. And in terms of stereochemistry, that's if the O approaches from the bottom. That's half the time. Half the time. And the other half of the time, it comes from the top. Black. And you got your thingy here. And well, this doesn't look like the O. There we go. There's one mangy looking epoxide there. Sorry about that. And that would put the H on a dash on top, wouldn't it? I hope you realize that all the names are the same except for the stereo centers, right? So we just got to find the right two products here. Think we can do it? Stereo centers 101. I'm doing the top stereo center. 1 for the O, 2 for a carbon that has an O, 3 for a carbon that doesn't have an O, and 4 for an H. And it's not S, therefore it is R. Bottom stereo center in purple. 1 for the same O, 2 for a carbon that has an O. Oh, why is that carbon with the O a higher priority than this carbon with the O? Oh, I think that's wrong, by the way. Maybe not. I think 2 and 3 are going to switch. Do we agree they're both carbon with an O? Carbon with an O. We agree. What else is on this carbon? A C is the next heaviest thing. What else is on this carbon? A C is the next heaviest thing. Back to the original C. What's the third thing on this C? H. What's the third thing on this C? Another C. We have a winner down there. Wasn't my intention for that stereo center to be that tricky. And that's the 3 up there. And our 4 is this carbon over here, right? Double switch necessary. You can't get away with guessing. And that puts the 4 where the 1 used to be. And the 3 is now downstairs, 2 is upstairs, and this one is S. So RS, and what's the enantiomer? S and R. You don't have to do the work over again. So there you go. Correct? Those two? Which choice? 50-50, 2 and 3. There you go. This last one is totally brand new. What you have to know about this is stated. Oh, it's not stated. It's on your handout, isn't it? I just didn't grab it from here, did I? Look at that. It's been there all along here. All right. Snipping. I stole this from my textbook. Pretty much. I stole it and then I edited it. So this dude, I'm gonna say a few mentions about this dude. Usually I don't talk about dudes at all, or ladies. But the guy's name is Barry Sharpless, that developed this chemistry. And he is a fascinating man. For many years, he's been the head of what's called the Scripps Research Institute. Some of you heard of Scripps, maybe? They sponsor the spelling bee. That's okay. But Scripps Research Institute is a wonderful place for scientists to work because they hire scientists from every field. Every field. They got biologists working with microbiologists, working with biochemists, working with organic chemists, working with oceanographers. Serious oceanographers, because they're in La Jolla, California, right on the ocean near San Diego. That's gorgeous. And they have a beautiful campus. And they go out there, and the oceanography people and the natural science people, they go look for new marine organisms. And they find them. And then they find out what new chemicals these organisms we've never seen before have in them. And they screen them against diseases. And then they pass on this information to the organic chemist and say, this chemical here had a real powerful a reaction against the cancer assay in a test tube. We need more of it so we can test it for, trials, right? And you only had like 5 milligrams of this stuff to start with, and that animal's gone. What do? Who do you pass this on to? Well, you figured out the structure of the chemical, you pass it on to the organic chemist, and they're going to make you a couple kilograms of this stuff, right? For pilot studies, et cetera. Anyway, Sharpless he was in charge of all that. It's fascinating. I don't know. Maybe TMI for you. And all you need to know is when you start seeing these tartrates, they're chiral. And if your special alkene that's called an allylic alcohol, it must be an allylic alcohol or else this reaction doesn't work. Allylic alcohol. If you draw your allylic alcohol so the double bond is on the left and the OH is on the right, like this bottom right, and I will try redrawing my molecule here so it looks a little closer. That looks a little closer to what's below, right? Sometimes you got to flip it. Sometimes you got to rotate 180, but you need the alkene on the left and the alcohol on the bottom right. And then this little guide works here. This little guide says if you have the minus tartrate, the epoxide is going to end up on above, up. There it is. Minus tartrate gives wedge. The plus tartrate, which is the enantiomer, gives dash. So, Mr. Sharpless gave us an opportunity. Normally, we got a 50-50 mix of epoxides, and we have to separate them. And when it's enantiomers, that is not an easy task, as we learned in chapter 3. So he's got a method where you don't even create the other enantiomer. You don't have to separate them if you didn't create them. And all we have to do is figure out how to draw the final product here. So you copy all the carbons. You copy your allylic alcohol. And it says here, point the epoxide to the right. And when it's minus, it's a wedge to the right. So you got to follow this guide carefully. Here's your epoxide. Wedges to the right. Okay? And for doing stereochemistry, we're going to have to do a dash here. And a dash here. Life got a little hard because we have an H there too. We'll do our work. 1, 2, 3, 4. Double switch time. We got a dash, wedge, 4. This switch with 3. And 1. Switch with 2. And that one is it's F. Purple. Purple. We got a 1. We got a 2, which is the C with the O. which slightly beats this C with the O. Same logic as before. And 4 is already on a dash. Small mercies, right? 1, 2, 3 is that. Double S and nothing else. Double S, nothing else. What's your answer? Yeah. As they say, end of semester. And we're out.